Hello, good day. Today we are going to look at how to determine your D10, D30, and D60 using interpolation. Now, I'm going to do this using the textbook I gave you as a PDF on Excel for civil engineers. I recommend this text. All you have to do is use this text along with your workings, the way I'm just doing it here. The essence of giving you this text in PDF is that when you install it in your system, you open it, as you read, you do. As you read, you do. With that, you are going to increase your expertise in Excel on how to use Excel to solve virtually every problem, both in civil, both in engineering, both in business, both in whatever. So that's the essence of giving you this text. So it's not just for you to keep this text inside your pocket and you are not using it. So you go through this text, go through these materials. There are a lot of things you're going to discover in these materials, and the best way to use this material is you read as you practice, or you practice as you read. Whatever you read from the text, you practice it immediately. That is why it's in PDF copy. Today we are looking at how to get D10, D30, and D60. And what is D10, D30, and D60 in civil analysis chart? Now, D10, D60, and D30 stands for D10 is 10%, the corresponding diameter opening that falls within 10%, and D20 is the corresponding percentage passing of 60% that falls within a particular diameter opening. Now, you know that when you check your percentage final, you might not see 10% exactly, you might not see 30% exactly, you might not see 60% exactly. You can see things that are within that range. So the only way to get this value is to do interpolation. Now, there are very different methods of interpolation. You can use formulas to interpolate. You can use graphical interpolation. You can use various means to interpolate. But here, we are going to use formula in Excel using what we call the trend line. Using trend, the function key is trend. So trend line, when you use your trend line, you can be able to determine the values of interpolated value. Now, what you are seeing on screen is a formula, a linear interpolation formula to determine a value, or x, whether x value or y value. Now, this is a linear interpolation formula. You can use this formula to interpolate any value. Like in this formula, y is the value that is being looked for. Y is the value that is being looked for. Y1 or yi is the value above the value being looked for. Yi plus 1 is the value that is greater than the value being looked for. So x1 is the corresponding, si is the corresponding value of to y in xi. X corresponds to y. In this instance, x is known, si is known. What you are looking for is y. Yi is known, yi plus 1 is known. So all these values, we put them together so as to get the value of y. Remember, it must be a linear value. It must be a linear value for you to use this equation. So let's go down and see. Now, what if you have a linear value but that has a semi-log graph? You know, in sieve analysis chart, we normally plot our graph in a semi-log graph. The x-axis is a log, while the y-axis is in the linear scale. So when you have a linear scale and a logarithmic scale at one side, x-axis is a logarithmic scale, while y-axis is linear scale. Are you going to see use the same formula? The answer is no. So this is the formula you're going to use. It's just the same thing, but the only difference here is that lane is added to each and every one of these. So when you juxtapose the formula, you get the final formula to be y is equal to yi brackets yi plus 1 over y1, then raised to power x minus si all over si plus 1 minus si. Now this is the formula we are going to be using now. This is the formula we're going to using now to interpolate. So to get our D1, D2, and D3, as the case may be. So we go on. So let's look at. Okay, this is an example that has been given. Please, you follow this thing judiciously and get your own values. It is believed that you have finished automating your sieve analysis charts. In the previous videos, I taught you how to automate your sieve analysis chart. It is believed that you have finished automating your sieve analysis chart and you have gotten your percentage final and grain size, that is sieve size. Now you want to find out your D10, D20, and all the rest of them. So now this is the way to go. This is the way to go. So we are going to use this formula to find to interpolate for these values. So we are going to go to our Excel and see how these things are done. So this is the formula we're going to use to find our D10, D30, and D60. Now please, let's look at this. You have the y, which is D10, x is D10, the value of D10 is known, is 10. Now what we are looking for, which is now stands at y, is this value here, and this value here. Okay, so our 10, 30, and 40 stands as x, while our 0.9, 0.3 stands as y. So now if we look at this place, we see that A10 is here. This is A10. Remember, we are looking for D10, and D10 falls between 2 and 24. D10 falls between 2 and 24, and we don't know the value of that D10. So but we know that it falls within the range of 24 and 2. 24 is the upper limit, y2 is the lower limit. So what it means is that 24 is yi plus 1 and y2 is yi. Remember, 24 is yi plus 1, y2.4 is yi. So if you look at this place now, we have A10. This is your A10, which is your yi. Then you have A11. This is your A11, which is your yi plus 1. I want you to remember this formula. Let's quickly go there. You can see what you're trying to say. yi plus 1 and yi. Please remember it, yi plus 1 and yi. So let's go back. So yi, which is A10, this is A10. So you have yi at this. Now the next thing you have is yi plus 1, which is 11, yi plus 1, which is 11. Now all over yi, which is this, now times raised to power x. So your D13, you can see this is the value that is known. That is the x value that we are looking for. So we have your D13 minus B10. This is your B10, the known value, and you know is a corresponding x, value all over B11. This is B11 minus B10. Remember, B11 is SI plus 1 and B10 is SI. So I believe this is clear. So what to do, we have to apply this thing on our Excel to see how it goes. So let's go to Excel. So here you have your values of D10, you have D30, you have your 16. So these are sieve sizes. Sorry, these are percentage passing. So you can see we have 100% passing, we have 27.6, we have this, and finally we have 10% passing, 30% passing, 60% passing, which we don't know their values and which we are looking for their values. And we want their values to be here, that is the corresponding percentage that is the corresponding shift size, of this percentage percent. So for us to do it, we're going to use the formula for interpolation for a linear scale and a log scale. So we put equals to. So the first thing you look for there is your yi. You're looking for y. So yi. So you come here. This is your yi. So the one that is on top, that this value we are looking for is within 24 and 2.4. Within 24 and 2.4. So because we're talking about 10 lies between 24 and 2.4. So what we now do here is, remember the formula, the first thing is yi. So yi here is this. Okay, can you see it? Because we are looking for y. So the yi is the first value, yi plus 1 is the second value as you are progressing down. So yi, you put star brackets. Remember the equation, the next thing is yi plus 1 all over yi. So you say yi plus 1, which is this, yi plus 1 all over yi. So let's go back to the equation to be sure we got the value. So we have yi bracket yi plus 1 all over yi. So we are in order. So you can see it. This is yi, which is there. Then we have yi plus 1, which is this. Then we have yi. We have all over yi, which is this. So the whole of these now will now be worked at raised to power. Press shift, raised to power, and put brackets, shift, brackets. Now you have x. So let's go back to the equation. So you have x minus xi, x minus xi. Now you come here. Now where is your x? Your x is the value that is already known, that is corresponding, that is the percentage passing, that is the x. So, and they say x minus si. So you have x, this is your x, and your si should be the value that is corresponding to yi. Remember, our yi is this. So yi is this, so our si is going to be this. Alright, so let's check, be sure of our formula. So you have x minus si, so another x minus si. So this This is our x minus si. So this is our si. This is our si. Bracket closes, or the next, all over si plus 1 minus si. So all over brackets si. So what is si plus 1? This is si plus 1 is this one, si plus 1 minus si plus 1 minus si. So these are si here, right? So we have si minus 1 as si. So this is our si plus 1 and this is our si. So we cover with brackets. So we have succeeded in writing the interpolated value. So once we are done with this, what we just do is to press enter and the value will appear. So press enter. It's a mix up somewhere. So how you know the value is correct is that the value is supposed to fall within 0.3 and 0.5. Remember, that's what we're looking for. We already have the values for D10, that is percentage passing, D30 and D60. So we are looking for the value of this. So and the D10 will fall within 0.15 and 0.13, and you can see that the value is 0.19. So you can see that it falls within these two values, so we are correct. So let's go back to this. I don't know whether you understand that something appeared when we finished doing this, and the reason is this, that we didn't put this after raised to power, we didn't bracket it together. See what I mean? If I remove this bracket here, I want us to understand so that we don't get confused when we are doing others. In Excel, everything, you must follow your board mass. You must follow your board mass. Everything must be done in your brackets should be used very well. If not, you're going to get wrong figures and you'll be thinking that you have a right answer. Look at it. You can see this, the value that we are having, minus 242 point something, which is erroneously wrong. Because whatever you calculate in Excel, you're going to have a value. You are going to have a value. So you must do the right things. You must put the right brackets. You must put the brackets where they're supposed to be. Any bracket you miss out to put, it will give you a value that is beyond, that is erroneous. So that is why we have to be careful. Now, if we add a bracket, have a bracket here and add another bracket here, you will see the answer will change. Now this is the correct answer to this question. So you can see how we have achieved this. So let's go over to D30. Let's see how we are going to get D30. D30 will be equals to it will be equal to, so look at your D30. Your D30 is going to fall between 24 and 70. It's going to fall between 24 and 70. So we follow the formula again. yi should be this times brackets open. So yi plus 1, which is this, all over yi, which is this. So we close brackets, raised to power. Now open brackets, x minus si, x minus si. So your x will be the D30. So you click here, minus si. So your si is this. This is your si. So bracket closes all over. Now you have si plus 1, which is this, minus si, which is this. So bracket closes. We didn't open bracket, so you go and put it. It's very important. So you now include every value, the second value, in a bracket. Press enter. You can see the value is 0.3275, which is around approximately 0.33. So which falls within this value and this value. So this is our D30 that we have gotten. So let's do for D60 as well. So you put equal to, so your D60, where does it fall? Your D60 falls between 88.5 and 70.6. 88.5 and 70.6. So now our first one is yi. So these are our yi. So click here, we say times brackets yi plus 1 all over yi brackets raised to power brackets x oh, I made a mistake. So this falls within this and this. So our yi should be this as brackets yi plus 1, which is this, divided by yi raised to power brackets x minus si brackets slash brackets si minus x minus x, so this si minus x. So cover everything in brackets So you can see that we have determined the value. The value of D60 falls within 0.7, which falls within 1.18 and 0.6. So we can see clearly how we can use interpolation to determine these values. So once you have done this, the system automatically gives you your D60, your D30, and your D10. So anytime, any day, you fix values for your sieve analysis, automatically the value of your D10, D60, and D30 changes. So if we change these values now to, let's say, 2.5, let's see what will happen. This should be 1.18, and this should be 0.80. This should be 0.425. This should be 0.075. This should be 0.115, 0.075, 0.065. You can see as we are inputting these values, the D10, D30, and D60 are changing. So you can see the values have changed. So you don't need to start doing this calculation on. So that's the essence of this. So as we are changing back, you see the values are changing. The same way, if your percentage passing values changes, the corresponding values are also going to change. So we have succeeded in doing this. So the next thing is to, with this calculation now, you can be able to calculate your value of CC, CU, and all the rest of them. So look at here, we have CU as D60 all over D10. So CU D60 over D10. So we have here, we see CU D60, these are D60. So you put your equal sign, D60 slash D10. So that's the value of CU. CC your CC, the value of CC is D30 squared all over D60 D10. D30 squared D60 D10. So we go D30, this 30, D30 raised to power 2 all over D60, you put brackets, most D60 times D10, bracket closes. So that's your value. So you can see that automatically you have automated this system to calculate D10, D30, and D60 for any type of receive analysis chart and give you the corresponding CU and CC. So with these values, you can now go ahead and do your classification, soil classification system. And a simple way of doing that is you are going to use what we call the conditional statement, the if command. I'm going to tell the system that if this happens, system should do this. And we know that for you to have a value, that is a range of value that you have to have your CU and CC for the soil to be well graded, or the soil to be uniformly graded. An example is this. So put equals to if input if you say this value here CU is less than is less than a particular value. Let's say it's greater than 5. Is greater than 5. You put comma. The system should say well graded. Remember, for you to put this well graded, you must use a double quotation mark. If not, the system will give you error. Double quotation mark, remember, because it's a string. It's a string. So if you don't use it, system will not honor it. So, and if it's not this, what will happen? If it's not this, what will happen? The system should specify whether is gap graded or whatever. So you can say if it's not this, you say gap graded. So the same thing you did here, double quotation mark, you say apply it, double quotation mark, and you cover your brackets. So you can see, can you see what happened here? Now the system is saying that the soil is gap graded. The soil is gap graded. So that is how we have these things play out. So anytime this thing is less than 4, the system will tell us that the soil is gap graded or well graded. So with this, you have done your soil classification system. Thank you for your time.